Welcome to new KNEW 7 polynomials adding and subtracting guided video tutorial. One thing I think you're going to notice about this video tutorial, or this week in general, that's a little bit different is these are a little bit shorter this week in general. I don't know, I just feel like the first 2 weeks it's a lot of information crammed into a chapter, whereas this chapter it's a little bit more, not condensed, but it's a little bit more focused. This chapter is a little bit more focused. So there aren't 4 methods of doing something. Plus, actually, the way that I break down the material, I break down this chapter actually into 2 weeks, because this is by far the most important chapter of this semester. So the new NEW stuff we will be doing that's linked to this is factoring. The review material that we are going to be doing is polynomials, which there is a direct link. The new KNEW, so the review material that we're going to be doing is polynomial. I could break this down even further back into combining like terms, but we're actually going to be reviewing that within the review. So I chose not to directly review that. We're going to indirectly be reviewing that by talking about some of those topics. So they will come up. So let's get started and we will see where we go. So we're going to talk about a couple things here. The first thing we're going to be doing is, the first thing that's going to be very important between this review video and the next review video is noticing what is in between our parentheses. So you'll see here in number 1 and number 2, there are addition signs in between the parentheses, which means we are adding, okay? That means that we are adding apples with apples and we are adding oranges with oranges, okay? That means if I have 2 apples on the table and then you come over and you put 3 more apples on the table, I take my 2 apples, I take your 3 apples, and I put them together and I get 5 apples, right? So another way to think about it is like in terms of money, because I can't have negative apples. That it doesn't always like compute in my brain. That doesn't always make sense. It's not logical, okay? But with money you can think in terms of like having it or owing it, right? So here, if I think in terms of, I have $6, but then I owe you $9, right? So if and you can do it in either order, it doesn't matter. So if I owe you $9 and then I pay you back 6, because you see that 6x is positive, I still owe you $3 at the end of the day, right? So I'm going to owe you $3 at the end of the day. Now, what we've done is combine like terms, which is it's in another chapter, but this is another review concept if you really think about it, if you really wanted to break it down. So we are reviewing within a review, which is important to note. So 6x minus 9x, okay, is negative 3x. I have 6, I take away 9, okay, and I get negative 3. Now you're saying like, well, why are you taking away? Well, even though I'm adding in between the parentheses, that 9x is negative, right? So 6 plus negative 9, that negative trumps. Okay, so 6x, I take away 9x, I get negative 3x. Now, I owe you $11. Okay, now like if you're talking about fruit, if we're using the fruit analogy, now we're talking about oranges. Okay, if we're going back to money, okay, I owe you $11 and then I owe you 4 more. So I borrow $11 from you and then I borrow $4 more from you. So I'm going more in the negative direction, right? I'm going more into the red, as they say. So I owe you 11, I owe you 4 more. That means I'm owing you $15 at the end of the day. So when I combine these polynomials, and again, I don't get caught up in the addition and the subtraction part of this. I'm more thinking I'm combining, right? Because at the end of the day, more than the plus or the minus in between the parentheses, what's in the parentheses, those signs matter more. I get negative 3x minus 15. Okay? And again, I have to keep apples with apples, oranges with oranges, meaning if it has an x, it only combines with other x's. If I have no x on it, then it combines only with other terms that have no x's on it. So let's look at number 2. If I want to start by highlighting my like terms to begin with, this 6x squared goes with this negative 8x squared. And again, I'm looking at my variable terms to decide what's like in this case. If it's an x squared, it goes with other x squareds. If it's an x term, it goes with other x terms. And I always grab the sign before it, so the positive or the negative before it. And this minus 6 goes with this positive 5. Because it's a plus in between the parentheses, meaning it's addition, I don't have to do anything about that. The plus it's the default. That's what I like. We'll see in the subtraction there's an extra step to it. All right, so now this 6x squared minus 8x squared, or I owe you 8x, but I pay you back 6, or I have 6x, but now I have to give you 8x. Okay, if I have 6x, but I have to give you, or if I have $6, but I have to give you $8, okay, I can't give you $8 because I don't have $8, I only have $6. So now, right, I basically owe you $2, or I owe you 2x squared. So it's negative. 5x, it's positive. Negative 3x, or I have $5, I give you 3 of them. I have $2 or 2x left. And then minus 6 or negative 6, positive 5 or plus 5. So I owe you 6 and I pay you back 5. I'm almost back to even, but not quite. I still owe you 1. And I'm all done. All right, so now here's the deal with the subtraction. So first step, you're always looking for what is in between your parentheses. So I'm looking at 3 and 4 at the same time. I see that I have these negatives or subtraction in between. I don't like subtraction because if you remember from solving equations, which these are not equations, they don't have an equal sign, but if I remember from solving equations, when I had that, negative or minus before a parenthesis, I had to distribute that minus or that negative to everything in that next parenthesis. So that same principle or that same property holds true here. So I have to remember to give that negative to this negative 3x and to this positive 5 or whatever's in there. I don't want to have to remember to do that because ultimately when I have to remember things like that, there's more of a likelihood that I will forget. So what I do is I do a variation of that, but I do it in the sense of, I didn't have any problem with the two above when I had to add. So I'm going to change my subtraction to addition. And if I do that, I need to change everything in my parenthesis to the opposite sign. Because basically I just changed the sign of my negative to a positive. So I switched the sign on that to the opposite. And when I do that, that means I have to change everything in the following parenthesis to the opposite sign. So this negative 3x becomes a positive 3x, and this positive 5 becomes a negative 5. So if I do it in number 4, we'll just do that while we're here doing this same step. Okay? I turn the negative to a positive, or the subtraction to an addition, and then this x to the third becomes a negative, x to the second becomes a negative, and negative 5x becomes a positive. I won't go in, you're going to have to trust me. This is one of those things that I ask you to trust me, okay? If you want the reasoning on why this works, it is simply because for the same reason that with systems, if you had, remember when you had, say you had x plus 2y equals 10, and we took that system and we multiplied it by negative 1, what did that do to the system? It made it negative x minus 2y equals negative 10. Multiplying something by a negative 1, it switched the sign for everything. So basically what I've done down here, here, and here, by switching my sign, I've multiplied that half by a negative 1. And I'm allowed to do it as long as I switch everything in that following parentheses by negative 1. Okay? And that's, the very, very short answer, and I ask you to trust me for the rest. But what that does is it makes your life a lot easier. So now that you have the addition sign, okay, we're going to do the same method. So I'm going to find like terms. So this 2x and this positive 3x now, and this negative 19 and this negative 5. And now 2x and 3x gets me 5x. Oh, this negative 19 and this negative 5. So I owe you $19. I owe you 5 more. So I owe you $24. And I'm all done. All right, so number 4, I'm finding like terms. So I have this 4x to the third matching with this negative x to the third. I have this x to the, 3x, positive 3x. Now, this does not match up with this x to the second because this negative x to the second has a 2 as an exponent. But this 3x matches with this 5x because they both just have an x with no exponent. I'm going to color and highlight this negative x squared purple, but it doesn't match with anything. It does not have a partner. So I have to remember that when I go to start combining my like terms here. So 4x to the third minus an x to the third, or 4x, I have $4 and I'm taking $1 away. I have 3x to the third. Now I actually switch to purple because I want to go in order with my exponents, so 3, 2, 1, 0. So I'm actually going to jump to the purple, even though it's the next thing in my first parenthesis is green. I'm actually going to go to the purple. So I have, nothing's combining with this purple term, negative x squared. So somewhere I owe somebody this $1, or this negative, negative 1x to the second. Now I jump back to this green, or the x term. So I have 3x plus 5x, which gets me plus 8x, and I'm done. And that was all for that review. Jump on over to the next one, which will be something more with polynomials, and let me know if you have any questions.